So this is probability exam problem number 50. A company buys a policy to insure its revenue in the event of major snowstorms that shut down business. The policy pays nothing for the first such snowstorm of the year and $10,000 for each one thereafter until the end of the year. The number of major snowstorms per year that shut down business is assumed to have a Poisson distribution with a mean of 1.5. What is the expected amount paid to the company under this policy during a 1-year period? So first, let's remember what Poisson looks like. So we have P of x is equal to x, which is e to the negative mu x all over x factorial. Okay, and the expected value of the random variable is just going to be mu. Another thing that I want to review is that if we have a constant times the random variable plus another constant, our answer is just going to be a times e of x plus b. Okay. Alright, I think that is all we need. So let's gather the information that is given. So we have that the mean is 1.5, which means that e of x is 1.5, and that is, I jumped the gun again, that is if x equals to the number of major snowstorms per year, so number of storms per year that shut down business. And then just because we're here already, I'm gonna let y equal to the payout that the insurance company makes to the business. So payout to business. Okay. So the mean is given. It's 1.5, which means that our PDF should be e to the negative 1.5, 1.5 to the x all over x factorial. And then I think that is all we need for now. Okay, so now in order to define our new random variable, which is the random variable for the payout to the business, let's see what it has. First of all, we're not going to get paid anything if there are no snowstorms. So if x equals 0, we get nothing. If x is greater than 1, we're going to get paid 10,000 times the number of snowstorms. But because the first snowstorm is not counted, I'm going to take out a 10,000 from here. Okay, so 10,000 if x is greater than or equal to 1. Okay, and what we want to find is e of y. Alrighty, and that should be easy enough. So e of y is equal to the sum of x equals 1. We say x equals 1 because that is our starting point. We don't start from here because our values is going to be 0. So we're starting from x equals 1 all the way to infinity of, and let's factor out 10,000 from here, x minus 1. So it's 10,000 times x minus 1, and then times the PDF, which is e to the negative 1.5, then 1.5 x all over x factorial. Okay. Just I want to start with x equals 0 because I want to use a trick. So I'm going to take out the I want to take out the x equals 0 portion of the sum. So I'm going to take it out. It's going to be minus 10,000 of 0 minus 1 e to the negative 1.5, 1.5 to the 0, and then 0 factorial. And then plus, we're going to end up with e of x equals 0 to infinity, 10,000 x minus 1, and then our PDF. I'm just going to write this, sorry. It's the same thing as this, I just got tired. Okay. Well, this is just e of 10,000 times x minus 1, isn't it? Okay. This means that by the rule that we discussed earlier, that this is just equal to e 10,000 x minus 10,000, and this is equal to 10,000 e of x minus 10,000. Okay. And we already know what e of x is. It's 1.5. So this is 10,000 times 1.5 minus 10,000. Alright, so we know this portion right here. Easy peasy. So let's simplify this portion. This is a negative, this is also a negative, so we're going to go with a positive. 10,000. This goes away, e to the negative 1.5. So then, if we put it all together, we end up with e of y is equal to 10,000 e to the negative 1.5 times, plus whatever this is. Alright, and this is going to be plus 5,000. So your answer should be 7,231. 7,231. Okay, I hope this helped.